Today, I'm going to be reviewing the Orico O7000 SSD. This is an entry-level 2TB Gen 4 SSD, and I'm going to be taking a look at its performance in a variety of situations to see in what workloads it does well in and what workloads it doesn't do quite so well in. As a disclaimer, Orico provided me with this SSD for the purpose of making this review, although no money changed hands. All of the testing numbers I have, as well as my thoughts on this drive, are those of my own, although Orico did provide me with a discount link I put in the video description if you are interested in this drive. Let's start off by taking a look at the drive physically. This is a M.2 M-Key 2280 SSD, meaning it's the standard SSD form factor that fits into most M.2 slots in different systems. It's a single-sided drive, meaning there's no components on the back side of the drive at all, and everything is located on the front. The interface used is a Gen 4x4 link, although it is backwards compatible if you have an older Gen 3 system. You just won't be able to utilize the full speeds on this drive. Peeling off the little sticker it has is a basic standard sticker with no copper or any sort of thermal management done by the sticker itself. Taking a look at the actual components used on this board is a Maxio MAP 1602A controller, which is kind of an entry-level Gen 4 DRAM-less controller that's designed for kind of this class of SSDs, along with 4 YMTC NAND packages, which are TLC and 512 GB each. Included in the package with the drive itself is a heatsink that covers both sides of the drives to reduce temperatures, although in my testing I didn't see this drive use a huge amount of power, and the heatsink isn't strictly needed if you're using it in something like a laptop where you can't install the heatsink, or you can also use a heatsink built into a motherboard, for example. Let's take a look at the performance of this drive and see how it measures up. Starting off with my performance testing, I initially run Crystal Disk Mark just to get an initial feel for the performance of this drive and an easy way for you to compare to all the many other drives out there on the internet. And upon running this test, I see that I get about 7 GB per second, like the box shows. So it looks like it's working well, and the random I/O appears to be pretty good at first glance too. But when it comes to testing drives, there's often a lot more than Crystal Disk Mark can show. And that's why I've gone out and created my own scripts that use FIO to test a variety of different workloads like sustained write performance, sync performance, and performance when full. If you want to take a look at all the different tests, I have it linked in the video description if you're curious about that. And taking a look at the benchmarks I ran initially shows about the same burst speed performance, and the fact that this drive is capable of doing quite good performance in the best case scenario. My tests also did show where the drive didn't do so well. Some of the scenarios where the drive struggles in include sustained writes, sync performance, and the performance of the drive when it is full. So this drive, like almost every other drive on the market, has an SLC buffer for writes, which means it can write data quickly initially, but once it's written some of that data initially, it has to go actually write it to the QLC drive part of the drive under the hood, which is quite a bit slower. I ran a full write on this drive twice. So I did it once it was empty, just writing it initially, and then I did another full write once the drive was already filled with data, so it has to actually overwrite existing data. When the drive is empty, the SLC buffer seems to use as much space as possible, so with QLC that would be a quarter of the drive, or about 500 GB. But when the drive is already full, that buffer is very small. And unfortunately, the QLC write speed struggles even more once it's already full and having to rewrite over already written cells. And I was seeing about 20 megabytes per second average performance writing a drive once it's already been written to. This is the worst of all the drives I've personally tested and taken a look at, but we'll talk more about how important that is in the real world later on. The next set of performance I saw that this drive struggled in is when the drive was already full of data. There seems to be a lot of tweaks that this drive, along with many others on the market, use if there's empty parts of the drive when it comes to making I/O faster, as it's empty and can just write to the empty cells. But when those cells already have data on them, it needs more processing. And unfortunately, this drive had the largest delta between the performance I saw when the drive was empty compared to when the drive was full, seeing on average about 20% of the performance on a full drive compared to an empty drive. So it definitely struggles in those workloads. Now, typically in a normal use case, you won't completely fill a drive, as the drive is capable of using trim to take a look at the empty space on your drive and give that back to the drive so it can use it for other workloads. Now, I didn't run these tests for every possible amount of filled percentage on this drive, and I did it with just completely empty and completely full, mostly because the testing already takes long enough the way it is on these slower drives, but it definitely seems like there is a drop-off performance as this drive is filled up. The next quick mention I want to make performance-wise is with sync workloads. These aren't super common in desktop tasks like just running Windows or Mac OS or Linux on the system, but if you're using workloads like a ZFS file system as a log drive, Ceph, databases that use sync, or other workloads, this drive performs very badly in those workloads, and I would stay away. So the big question after all this artificial testing is, does this matter in the real world? My artificial benchmark is designed to push the drive to its limits to see where does it struggle. So I wanted to take this drive and also just use it in my desktop for a bit as kind of more of a games drive and other media drive to see if I'd see those big performance drop-offs I can see in artificial workloads. So when it comes to just downloading games, for example, I have a gigabit network connection I tested with, and I could never get the drive to fill up even after downloading about 1 terabyte of drives, which I think is a worst case scenario for most consumers. Now, another intensive workload that I personally use is having cameras where you may have fast cards. CF Express can read at maybe 1 gigabyte per second, which can fill the buffer quickly. Now, many older cameras have slower media cards where that won't be an issue, but if you're shooting raw video or something where you need the highest workloads, you'll run into that. But for lower workloads where you're using smaller files, you'll likely be most of your time in that SLC buffer and not see the huge performance drop-off of the actual QLC NAND being written to. And if you leave a bit of free space on the drive, that'll really improve the amount of size of that SLC buffer and the amount of writes you can do to the drive before the performance drops off significantly. My overall conclusion performance-wise with this drive is if you're using it for something like a desktop workload where you're launching games or running Windows or copying files around occasionally for something like a camera, this drive is likely going to be fine performance-wise, and you're not going to see any of the major drop-offs that I saw in my artificial testing. As you'll likely in these workloads give the drive plenty of idle time to move data around as it needs, and if you aren't using some of the worst case scenarios for this drive, like sync workloads for databases or Ceph, for example, or filling the drive completely or being unable to use trim, or if you're copying huge amounts of files where you're going to see the very slow QLC NAND under the hood, performance is likely going to be fine for that desktop use case. When looking at products that would work fine for my use case, what I like to do is take a look at kind of a pricing tier and see where this drive lines up on it and see what moving up the pricing ladder or down the pricing ladder would get me to see if this is kind of where I want to be in the pricing ladder. So starting off at the very bottom for 2 terabyte storage capacity devices, we have hard drives at about $65. These are getting extremely slow for things like running an OS and even pretty slow for a lot of games these days. Moving up a tier at about $90 to $100, we have the most basic SATA SSDs. These are generally smaller brand names or lesser known brand names, and likely going to be SATA, DRAM-less, and probably QLC under the hood. Moving up one more tier at about $110, we have drives like this Orico O7000. This is giving you the NVMe interface, which does give you much faster burst performance, which does have the benefit if you're like verifying game files. If you're copying files around, those bursty speeds can definitely speed stuff up at times. And being able to use NVMe gives you slightly lower CPU overhead, though that probably doesn't matter. And host media bus does reduce some of the impact of not having DRAM. Now we can continue to move up the pricing ladder to maybe about $140 to $150, which gives us more premium DRAM-less drives. These drives typically have TLC NAND so that the performance drop-off for sustained writes is going to be much less. They also generally have a bit faster controllers for slightly better random I/O. Then moving up even more, nearing $200, we're going to start seeing drives that are the higher-end drives with DRAM, TLC, or sometimes MLC, and the highest-end controllers, and these days Gen 5 interfaces. Taking a look at where this drive sits in the pricing ladder, I can definitely justify going as an SSD over a hard drive, so I'm going to knock that off as a non-option for most people. I think this drive for maybe about $10 to $15, depending on the current prices, can definitely make a lot of sense over a SATA SSD. I think we're getting to the point where you're going to start to notice in some use cases an NVMe drive with the faster bus speeds to make a difference. Is it going to be night and day? Probably not. But since it's probably going to fit into your system better now because it's going to go directly on the board, the random I/O performance is faster, so some game operations like updates or verifying files is also going to be faster. I think I can say it's going to be justifiable for kind of a desktop bursty I/O performance and where it would make sense. Moving up a ladder even more to the higher end TLC drives, I probably wouldn't pick them for a gaming PC. I mean, if I couldn't get this drive to show a major performance drop-off for a gaming PC, I don't see a reason to go higher end for a lot of gaming uses. Now, if I am copying files from a card, for example, doing video editing, I need that sustained performance. I can definitely see the drives making sense, and if I need the best, moving up even more could make sense. But if you're in a desktop use case and want a reasonable drive, I think it can make sense depending on what the pricing is for this situation. Big thank you to Oracle for actually providing samples to reviewers like me so people can get a fuller picture than what the little marketing on the back of the drive provides. Do you have this drive? What are your thoughts on the drive? Do you think lower end NVMe drives make sense to you, or where would you pick one of these systems and not another? Let me know in the comments below, and also let me know if you want me to make changes to how I test drives, test more drives in the future, less drives in the future, or look at a specific drive. Thanks for watching this video, and looking forward to reading the comments.